when drawing a derivative graph, we have to look at the first derivative. That's what we're drawing it of. So the first derivative is the gradient. So we're looking at the gradient of the original graph. But we're not only looking at that. So we've learnt that there are points that are non-differentiable, non-continuous, and all of those sort of parts which we have to bring into whatever we draw. So I'm just going to make up a graph here. So here's a graph. Woohoo! Okay, lots of bits and pieces happening on this graph. What we are actually trying to do is look at each bit individually and assess the gradient of it. Now, technically, it should have nice arrows on the end if it's continuing, or it should have dots on the end if it's not. So this first bit is a straight line. We know that the derivative of a straight line like that becomes a straight line like that, a constant, right? So we've got to assess approximately what the gradient is and put that straight line in the right place. So looking at this graph, just looking at this little triangle here, I can see it's approximately 1 over 1, all right? Could be 10 over 10 because I've got no numbers on it. Doesn't really matter. I'm going to assume that if it's 10 over 10, it's still going to be about 1. So we're going to assume that it's 1, and I'm going to put this in. So I'm going to assume that's 1 and negative 1. And I'm going to put this bit here and here. All right? The gradient of this line forever will be 1. Now, the next point along is a point that jumps. And we've learned that if you take the pen off the paper in a graph, then it is not continuous. And because it's not continuous, it's not differentiable. So we've got a point here that we can't have a derivative for. So we have to put in our critical here. All right, there is no point there. Right, then we move on to the next one. So from here to here, this is a critical point, turning point, maximum. So therefore what? Yeah, it's on the line, right? The first derivative will be 0. So we've got that piece of information. On this side, we've got what kind of gradients? Positive gradients, negative gradients. Oh, here we change, about here it changed and about here. So we've got, oops. All right. At this point here, we also need a first derivative of 0 gradient, or a maximum gradient. And we need the gradient of this point to be 0. So therefore, what will happen is that we've got a positive gradient, a negative gradient, and then a positive gradient unto this point here. So it starts off really steep and becomes less. So it is quadratic. Then it goes really steep, which is up here. And then the steep part is in here somewhere, and then there's a point in here somewhere. I'm going to put that point here. It's actually way down here because it's very, very... gradient here is really, really steep, right? So what we're going to get is not so steep here, so I haven't gone as high. All right? This side seems to be steeper than this side, according to my visual look. So I've gone higher here than I have here, because this is the steepness. High steepness, low steepness, no steepness, negative steepness, low steepness, higher steepness, really, really high steepness down here somewhere, back up here, da-lee-da-lee-da, right? Negatives, negatives, going downhill, negatives, going uphill, positives, etc., etc. Then we reach this bit. This bit is a sharp turn. In our description of differentiability, we cannot differentiate at sharp turns. So we need to have a critical here. Right? There is no point. So this could be a filled in one. No, it can't because it's got empty dot. More empty dots. Empty dot. Right, so now we've got this one. Gradient, 0. So we have to jump from here to here, still with no, and have 0. All right, so you're doing each bit in turn and deciphering each bit, but the pieces you need to address are the bits where they join up. So if you have an asymptote, you're going to get steep, steep gradients. So you're going to have an asymptote in your derivative graph as well, aren't you? Because you're getting really, 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 really close to infinity gradient, but you'll never get there. So there'll be a dotted line there rather than an empty dot. As such, you could think of this as an asymptote. Couldn't you? There are no points that touch this line. It's just we don't write it as an asymptote because that straight line gets an empty dot, this gradient gets an empty dot. All right. So